Lithium. I bet you heard this name somewhere. Nowadays, it's mainly associated with batteries, since the most powerful of them rely on this lithium for all their power. Lithium also happens to be a popular medication, being the gold standard for managing bipolar disorder and some types of depression, which are among the most prevalent mental illnesses faced today. For those a little more into chemistry, lithium is also the name of a soft, colorful and explosive metal, and to be honest, these three lithiums don't seem related at all. However, what if I told you that the same lithium that powers batteries can become a life-saving medication while also being hella explosive? Well, this is just a glimpse into the wonderful world of chemistry, and today I want to take you on a journey and show you how I made bipolar meds from batteries in my garage. All this started a few months ago in the midst of a midnight Wikipedia surfing session, during which I experienced what I can only describe as chemical enlightenment, and in like half an hour managed to scrape together a rough outline of this project. What's even better, on paper it all looked really easy and seemed like the perfect video idea for a channel about amateur chemistry. That's why, guided only by the promise of doing something seemingly impossible, I bought this pack of 10 lithium metal batteries and started pondering. I figured that whatever the future steps might be, I would have to somehow get the lithium out of the batteries, and since that surely means destroying them, I decided that first I might as well see what the lithium power fuss is all about. Without even opening the box, I could tell that these batteries are special, since they have a shelf life of 25 years and feel weirdly light, with each one weighing just 15 grams, which is nearly 10 grams lower compared to a regular alkaline battery. Those lithium goobers also have better capacity and higher voltage, and overall seem to contain a lot more juice for powering things. This is cool and all, but for a chemist, the real beauty of these things lies deep inside them. They not only contain lithium, which is a rare element to come by, but they also contain it as a pure metal, which might not sound like a lot, but makes all the difference when one wants to make them into pills. Before getting to that though, I need to figure out how to break the batteries open to get the lithium, since unlike the alkaline ones, they are built to withstand a lot. Normally, this is very good, since bending or cutting these guys in nearly any way results in a short circuit, releasing all their power at once. This is one way to try making your own sun, and I wouldn't really want it to happen to me. That's why I resorted to using a sophisticated method of opening the batteries, involving this dollar store pipe cutter. When I plopped the first battery into it, I began feeling quite nervous, since I have to cut the steel casing just deep enough so that it easily slides off, and if I go even a tiny bit further, I risk having the whole thing burst into flames. The precision required here is nearly surgical, and you can imagine the relief I felt when I managed to split the casing without anything exploding. Then, using some big pliers, I tried to free the guts of the battery from the casing, which required a surprising amount of effort, and I think that I did end up shorting the battery at least a little. The whole thing also ended up getting really messy, but luckily I was finally able to remove the whole shell, leaving me with this warm battery roll. Inside it, apart from some unimportant battery organs, resides this thin, shiny metal foil, and this, ladies and gentlemen, is pure lithium. When I saw it for the first time, I probably looked like Gollum looking at his ring, and after freeing my precious metal, I quickly folded it up into this small chunk. Unlike any regular metal, this stuff began tarnishing seconds after being exposed to the air, and that's because lithium is very chemically angry and eager to react with nearly anything. To better showcase this, I first cut my lithium chunk in half using a pair of scissors, which is possible because it has a texture similar to clay, and then folded one of the pieces into this little ball. I was easily able to set it on fire, and at first it didn't look like this metal fire has anything special going for it, but after a few seconds, it looked like I ended up summoning the sun after all. I mean, the flame was so bright, my eyes hurt just looking at it, and it left behind what looked like glowing cauliflower. This shows just how much energy is stored in a lithium battery, and to make my pills I will need to figure out how to tame lithium's fiery nature. However, I had to first take care of the rest of my batteries, and I decided to use 3 for other experiments, leaving 7 for making my pills, and this should be more than enough. Opening them was just as stressful as before, with some behaving quite unexpectedly, and when I was finally done, I was really glad this was over. Apart from this bag of decapitated battery corpses, I was left with what looked like a good bit of lithium metal in this battle. It all amounted to roughly 6.3 grams, or exactly 0.9 grams per battery, which objectively speaking is not a lot, but since lithium is the lightest metal, a small amount can go a long way. Alright, so now that I have pure lithium, it's time to make it into some bipolar meds, and for that I need to take care of the fire problem. You see, since it doesn't really matter what form of lithium you ingest for it to have an effect, some bright souls might think that you could just eat the metal. If you were to eat lithium metal, it would react with the water in your body, instantly melting and letting off a bunch of hydrogen gas, which when mixed with air in your digestive tract could make you explode from the inside if the lithium ignites. What's even better, lithium metal itself can also explode if it gets hot enough. In this molten form, it is also one of the most corrosive substances I ever came across, and I lost not 1, but 2 perfectly fine beakers to it. Apart from the whole explosions and fire thing, when lithium reacts with water, it also generates the very dangerous lithium hydroxide, which is alkaline and turns this indicator paper deep blue. As you can see, the biggest problem in turning lithium metal into a medication is coming up with something to sequester its violent nature so that it won't explode if you eat it. I figured that the best way to start calming it down was to turn it all into lithium hydroxide, which, while still really corrosive and dangerous, isn't nearly as bad as the metal. The trick here was doing it without dying, since if I just chucked lithium from 7 batteries into water, there is only one possible outcome. That's why I came up with this little setup consisting of a beaker filled with distilled water sitting on a hot plate and vigorously stirred. This way, when I add in tiny pieces of lithium, it floats to the middle and doesn't have enough time to ignite and wreck the beaker, which is hella nice if you ask me. Adding all my lithium as these tiny chunks was tedious as hell, but gave me a lot of control over the reaction, so that when everything started warming up more than I would like, I just plugged the beaker into an ice bath and continued adding the lithium without breaking a sweat. Compared to all the stress I experienced before, this reaction was weirdly calming, and I was kind of hoping it would last longer than it did. Like all good things in life, however, it was over before I could really enjoy it, and with all my lithium dissolved, I passed everything through a vacuum filter to remove any insoluble junk, leaving me with this flask full of a concentrated lithium hydroxide solution. It looked very pretty, and now I have to figure out how to make my lithium even more family friendly. Having it as a hydroxide is quite beneficial because it allows me to easily make it into many different compounds, and among the safest ones we have lithium chloride, lithium citrate and lithium carbonate. Each of these has a history as a mood stabilizer, but the first 2 are kind of trash, and that's not because of their safety, but rather their insane attraction towards water. Lithium carbonate, on the other hand, is much more chill and has one highly unusual property that will make purifying it very easy, which is exactly why I decided to make it. Making it from lithium hydroxide is also suspiciously simple, since all I have to do is just combine it with carbon dioxide. I mean, this stuff is literally in the air, and my first idea was just to let the hydroxide solution stir for a few hours, hoping that it would absorb some carbon dioxide on its own. After 3 hours, however, nothing seems to happen, and since this is roughly the time it takes for my patience reserves to run out, I quickly whipped up a carbon dioxide generator using baking soda and sulfuric acid. I then submerged its outlet into the lithium hydroxide solution, and when I began combining the acid with baking soda, a ton of pure carbon dioxide started evolving and making its way through the apparatus. It didn't take long for it to start reacting with the lithium hydroxide, resulting in the solution getting increasingly cloudy from all the lithium carbonate precipitating out. Much like the previous reaction, this one went weirdly nice and smooth, well, maybe except the part where the outlet tube clogged and I had to implement a quick fix. Anyway, I let the whole thing run for a little over 2 hours, and to check if any lithium hydroxide remained, I tested the solution using an indicator paper. This time it turned green, which tells me that there is no more free lithium hydroxide to make the solution alkaline, meaning that all of it reacted away. I was quite happy about this, since it meant that the hard part's basically over, and to finally make my pills, I have to purify the lithium carbonate a little. For that, I got rid of the carbon dioxide generator and began strongly heating the lithium-containing beaker. This does 2 very important things, the first one being the decomposition of lithium bicarbonate. This stuff can form when too much carbon dioxide reacts with lithium hydroxide, and it is quite soluble in water, so by destroying it using heat, I get that juicy few % of additional yield. The second good thing about boiling the solution is the quick purification of my product, since while most impurities dissolve at high temperature, lithium carbonate's solubility actually goes down. This is the unusual property I talked about earlier, and while it is usually pretty annoying, here it's just perfect. After boiling the solution for an hour, I figured it was ready and passed it through a hot vacuum filter to remove all the dirty water. To make my product even more pristine, I washed it twice with boiling distilled water and once with acetone. The acetone washing also really helped with drying this stuff, since just by leaving the vacuum filter running for a while, I was able to dry it pretty much completely. Now, to see my product in its full glory, I whipped out this small bottle and proceeded to transfer it all inside using a funnel. Lo and behold, this is officially pure lithium carbonate made from batteries, and I wasn't amazed only by how nice and clean it looks, but by the apparent 90% yield I managed to achieve. Hell yeah! This yield is honestly just beautiful, because it is high enough that I know I didn't screw up anywhere, and at the same time low enough that I don't need to question my chemistry skills and wonder if it's really the thing I want. Instead, I can just sit back and enjoy that my work didn't result in a failure for once, and this made me especially look forward to finally making my pills. First, however, I have to put up a disclaimer that everything you see in this video is done only to explore the science behind everyday objects. This is by no means a tutorial, and I hope that I made it clear just how dangerous what I do here is, and that things presented here are not to be replicated by anybody with inadequate experience and safety measures. Also, I am in no way encouraging the practice of self-medicating with any chemical you make yourself, because consuming biologically active substances riddled with unknown impurities and without professional supervision can have way more terrifying consequences than one can imagine. Okay, so with this out of the way, let's make some lithium carbonate pills for science. For that, I first had to obtain some empty pills, and the easiest way I could get some was using my creatine container, which has all the creatine stuffed inside these chunky capsules. I emptied 5 of them, and then had to figure out a way to stuff them with my lithium carbonate without making a big mess. At first, I really had no idea, but then I found this legendary tiny funnel, which is probably the cutest piece of glassware I own. I then assembled it into this cursed contraption, which made filling up the pills quite easy, and it didn't take long to take care of all 5. Making my own pills was quite a weird feeling, and what weirded me out even more is that they looked indistinguishable from the real deal. That's why I stashed them in a completely innocent plastic bag labeled "Do Not Eat" and began thinking about what to do with them. First, I wanted to simulate how they dissolve in the stomach, so I assembled this biblically accurate stomach consisting of a test tube filled with concentrated hydrochloric acid, and upon dropping one of my pills in, nothing happened. That's good, because this means that the gelatin shell can protect it for a while. But like most things in contact with acid, it didn't take long for it to give up. This allows the lithium carbonate to mix with my simulated stomach juice to form lithium chloride and release all the carbon dioxide I trapped in it, splashing everything around it with the aforementioned corrosive acid. This is cool and all, but it's honestly kinda boring, so I went on an extra hard thinking session to figure out a better use for my pills. Fortunately, there is one more amazing thing about lithium my pills can showcase real well. If I take one and get all its contents into a container, then lightly wet it with dilute nitric acid and methanol, and light it on fire, something beautiful happens. Instead of being yellow or blue, the fire takes on this reddish, nearly magenta color, and it looks just delightful, especially in the dark. It's all because of lithium ions from the lithium carbonate that penetrate the flame, and if the temperature is high enough, they begin to emit a very specific wavelength of light, which just so happens to be one of the most beautiful colors. This property is also used to confirm the presence of lithium ions in something, and for me it really cements just how special and wonderful this element is. As I researched for this project and did all the experiments you've just seen, I kind of fell in love with lithium, as far as you can fall in love with an element, and if I had to rank all the elements, lithium would definitely be in the top 5. Recording projects like these always reminds me of just how magical chemistry is, and I hope that by turning batteries into bipolar meds, a homemade sun and cool flames, I shared at least a little of my love for chemistry with you. Also, thank you all for the mountains of support you give me, it really keeps this channel going, and I especially want to thank all my Patreons who directly fund these videos. If you'd like to get access to a lot of exclusive content, including behind the scenes, early access to videos and updates on my new projects, you can also join my Patreon, and see you guys in my next video.